Hello and welcome to our Unit 6 study guide number 2. I hope that by the time we're done with these 12 questions, you feel better prepared for your exam. So let's jump in with number 1. Okay, match each graph. So the first thing that I notice is my base, which determines whether I'm growth or decay. The base in every case is equal to E. And E is approximately 2.718 something. So if my base is E, then I know that this curve is going to be growth. This curve will also be growth, and so will this one. Now, the one in the middle will be decay because notice the negative in the exponent. So I will rewrite this instead of E over 1, it's really 1 over E to the power of x, meaning this is actually a decay curve. My base is now less than 1. So the only graph that decays here is the one on the right. All of these start low and go high, whereas the one on the right starts high and then it drops down. So let's label that B. Okay, next. Notice between A, C, and D that only A has a horizontal asymptote, has a number being added at the end, because this guy's horizontal asymptote is 0. And for D, the horizontal asymptote, the big number being added at the end is 0. So that means that A, graph A, has to be right here, since its horizontal asymptote occurs at y equals 4. Okay, so now we're down to C and D. So notice that the only difference here is what's happening in the exponent. To figure out which graph is which, I will plug in some points. So let's say that for letter C and D, I'll plug in the value 0 into my x. Well, if I want to see what e to the power of 0 is, I'll just plug it in for x right there. And e to the power of 0 is 1, meaning that my y value comes out to be 1. So now I know that I have a point I need to go through of 0, 1. So let's see which graph goes through 0, 1. This graph does, whereas this graph misses 0, 1. So I know that the graph on the left will be C, and just by process of elimination, this guy will be D. But I'll confirm it just in case. Let's do an XY over here and make sure that we get the right point. Okay, so this time a good number to plug in for x might be -2, and you'll see why in a second. If I do, I could call it f of -2, or I could just call it y. E to the power of, now I'm plugging in -2 in for x. So -2 plus 2 gives me y equals e to the power of 0, and that gives me y equals 1. So I know that for D, it has to go through the point -2, which is right here, -2, 1, there it is. So I do confirm that this is D. Okay, moving on to number 2, solve the equation. So notice that on the left side and the right side, 6 and 36, I can write both with a common base. So on the left, I'll leave 6 as 6 to the power of x plus 3, whereas on the right side, I want to get a common base, so I'll write it as 6 squared. Now that I have the same base on the left and on the right, I know that my exponents have to be equal. So I get x plus 3 equals 2. Solving for x, I find that x equals -1. Okay, and I can plug that back in just to check. So I have 6 to the -1 plus 3 equals 36. -1 plus 3 is 6 squared. And this is true, so I know that I did my work correctly. Moving on to number 3. Okay, it says f of x equals 3 to the power of x. Is this growth or decay? So I know that it's growth because I just have to look at the base. If the base is greater than 1, it's growth. And if the base is less than 1, it's decay. In this case, my base is 3, so I know I'll be growth since that's greater than 1. Okay, so to graph a growth curve, I know first I need a horizontal asymptote. In this case, the number being added at the end is 0, so I'll label that the horizontal asymptote is y equals 0. It is growth. And I need a critical point, so I'll plug in 0 into my x value, and I'll have 3 to the power of 0, which gives me 1 as my y. So that'll be y equals 1 when x equals 0. I'll plug that in right here. So here we go. Let's graph what we know. We have an asymptote at 0. We go through the point 0, 1. And we're growth, so we're going to start low and then grow high. Just like that. Beautiful. Now, if instead of being 3 to the x, this had said 3 to the negative x, or 1/3 to the power of x, these would both have been decay. Since in the left case, I would have to rewrite that. Negative exponent means flip the base. So here my base is actually 3/1. That's the same thing as 3. So that means it would become 1/3 to the power of x, which as you can see is the same as what we have on the right. Both of these would be decay since the base, which in this case is 1/3, is less than 1. In case you see that on an exam, just keep in mind that's what you're looking for. Okay, moving on to number 4. Convert the logarithm. So to convert from a log form to exponential, you always bring the exponent down first. So my exponent in this case is 3. I'll bring it down first. It's immediately followed by equal sign. And since I'm going into log form, the word log should definitely appear. Now, I need to figure out what my base is. The base is small and it goes down here, which will be 4 since that's the base of the exponent. And the only remaining number is 64. Here's another example. What if I had said 1/32 equals 2 to the negative 5? Still, you bring down the exponent first, equals log base. Now, which one's my base? It's the guy under the exponent, so make sure you do the 2. And then the only remaining is 1/32. Just like that. Okay, so this problem is super easy. Please don't miss it on the test. Number 5. Okay, for number 5, they're giving me a graph. And let's select basically true or false on each of these. So is the domain from -infinity until 1? If the domain is from -infinity till 1, it means that the graph stops right here. That it only exists from the left side from -infinity until 1. But as you can see, the graph actually goes on forever to the right. So it does continue past that line. Therefore, the domain is actually -infinity to +infinity, and this would be wrong. Next, the range from -infinity to 0. That means that the graph exists down here from -infinity up until 0. As you can see, this is actually flipped because the range is actually from 0 till infinity, right? My graph begins here at this line and goes up forever. So that would be false. Next, C. I'm going to select true on C, and the reason is 5 to the power of x represents a growth curve. And as you can see, this is growing. And if I plug in numbers for x, I'll get 0 in for x. 5 to the 0 gives me 1. And if I plug in 1 for my x value, then 5 to the power of 1 gives me 5. And you can see that the points actually line up. So I can verify C is the correct graph. Y-intercept at 1, 0. So this one's tricky because the y-intercept is at 0, 1, but they said 1, 0. So you can see they're trying to trick me. See if I'm paying attention. The y-intercept actually is 0, 1. Okay. It says for letter E, this is a decay function. No, this is false because we know decay functions start high and then decay downwards, whereas this one's actually growing. So this is actually a growth function. And then for F, as x approaches negative infinity, so we're talking about the left side. So as we move further and further left, my y value is approaching. As you can see, based on the asymptote, I'm getting closer and closer and closer to the value of 0. So this will be true. If I said what's happening as x approaches positive infinity, then you'd look at the right side, and you would see that the graph as I move to the right actually goes towards positive infinity. But on the left, it's getting closer to the value of 0 right over here. So this is true. Okay, let's move on to number 6. It says to solve. So remember, in solving log equations, there are two formats. I call this guy situation 1, where I have log of x equals log of y. When we have logs on both sides, we just set the inside guys equal. There's really not much work to do at all. So that's situation number 1. In situation number 2, it's slightly different. It's like log x equals y. Notice this time I only have one log, and it's on the left side. So in this case, you can't just set x equal to y. You have to ask yourself, okay, what form am I in right now? Well, right now I'm in log form. So I'm going to have to go into exponential form if I want to solve for x. So we'll start at the base, and it's b to the power of y equals x. And that's how you'll solve the second form. Well, if you look at the question in front of us, it doesn't really look like either of these situations because notice there are 3 logs in total. Your first job is to make sure you only have 1 log on each side of the equal sign. So that means I'm going to have to condense the left side. Here's how I will condense it. Instead of natural log being in 2 places, I'm going to condense it to 1 natural log. And I know that x plus 1 is going to go in the numerator because there's a positive sign out in front, so it goes in the top. And I know that the 4 is going to go in the denominator because there's a negative in front of my 4, so it's going to look like this. Divided by 4 equals, and on the right side I only have 1 log, so I'll leave it natural log 2. So now have a look. On the left side I have only 1 log. On the right side I have 1 log, so that means this is a situation 1 problem where I can very simply just cross out the logs and set the inside guys equal to each other. So I have x plus 1 all over 4 equals 2. I want to solve for x, so let's multiply both sides by 4 and get rid of that denominator. So multiplying by 4 leaves us with x plus 1 equals 8. And solving for x, I get x equal to 7. This is my final answer. But before I finish, I want to just make sure, because remember, we have a couple of rules. You can't ever take log of a negative number, and you can never take log of 0, because both will give me does not exist. So let's just make sure that we're not breaking any rules with x equals 7. So mentally, I'm going to plug it in right here, and it gives me natural log of 7 plus 1 is 8. Now, I don't actually have to solve this, but I'm just checking that when I plug in x, I don't end up taking log of a negative number. Since it's just natural log of 8, and 8 is positive, I can do that. It checks out. So this is my answer. Moving on to number 7. So another similar problem. We have a log equation, and notice that this time we have to condense the left side again. There are 1 log 2 logs, and I need to condense it down to just 1. So I'll go ahead and start by writing my 1 big log, base 3. And this time, I have an exponent I need to rewrite. That 2 moves into the exponent position and leaves me with a 4, again in the top, because there's a plus sign out in front. And this x plus 3 is also going to go in the top because of the plus sign in front. They multiply together, don't forget that. Equals 2. So this time, notice I have only 1 log on the left, no log on the right. So that means I'm in situation 2, where I have to go from log form to exponential form. So let's have a look here. My base is 3, so I'm going to write my next step. 3 to the power of 2 equals all that inside stuff. So 3 to the power of 2 equals 4 parentheses x plus 3. I'm going to distribute that out and simplify the left side. 3 squared becomes 9. And that's 4x plus 12. And I'll finish solving for x. Minus 12. I'll have negative 3 equals 4x. And dividing by 4, I get x equals negative 3 over 4. That's my final answer. But first, as before, we'll just plug it in and check. So when I plug in negative 3 over 4, right here, I'll end up with log of negative 3 over 4 plus 3. Well, negative 3 over 4 is something like negative 0.75 plus 3. I know that's going to end up giving me a positive answer, so I'm good. We've checked out. Number 8, find a solution. Okay, so this problem is really similar to number 2. So we had 6 on the left, a 36 on the right, and I said, okay, I'll find a common base. And in the last case, the base was 6, because I could rewrite both 6 and 36 as powers of 6. This time, my bases are 8 and 32. So when I find a common base, I can write both 8 and 32 as powers of 2 this time. So let's start with the left side. Rewriting 8 as 2 cubed, the power of x minus 2. And on the right side, 32 is 2 to the 5th. So we have common bases. So we'll set our exponents equal. But remember, a power to a power means we're going to have to multiply. So this is what we got. In my next step, that'll say 3x minus 6 equals 5. In my next step, I'll start getting x by itself. 3x equals 11. And in the final step, dividing both sides by 3, I get x equals 11 over 3. So once again, once we have a common base, we can just set our exponents equal. In this case, you just have to remember that the power to a power will multiply and distribute. So we got 3x minus 6, and on the right side, it was just 5. Okay, number 9. Approximate the value of log base 8 of 40 to 3 decimal places. So for this problem, you have to remember a formula that we learned. I believe it was from 6.8, called the change of base formula. And it says if you have a log with some base of some number, that it's actually the same if you rewrite it as log of t over log of b. Notice that the base became the number in the bottom. So I remember it always base in the bottom. They both start with b's. That's a very easy way to remember. So log base 8 of 40 is actually the same as log of 40 over log of, I'm going to put my base in the bottom, log of 8. Once I have it written like this, I can plug it into my calculator. So let's see. Let me pull up my calculator. Where is it? Oh my gosh. There it is. So I'm going to first hit log of, it was log of 40, close parentheses, and divide that by log of 8, close parentheses, 1.77397. So I got 1.77397, but it wants me to approximate to 3 decimal places, so I will just ignore this guy. I only need the 4th one to realize that this will round up. So my answer is 1.774. All right, number 9. So you want to identify growth or decay for each. So first, remember, only the base matters. So look at the base. So if I have a times b to the power of x, I'm only going to look at b to see if it's growth or decay. If it's greater than 1, it's growth. And if it's less than 1, it's decay. And I ignore the number in the front. So that's the first easiest thing you can do, is just cross out the number in front so you can focus on the base. Since 2.5 is greater than 1, that's growth. Again, the second one, cross out the number in front, only look at the base. So 2 divided by 3 is, you can think of it, you can put it into your calculator and you'll see it's 0.666667 repeating, right? Lots of 6's forever. That's less than 1. So that's going to be decay. The other way you can tell with fractions, if you're not sure, is if the top is smaller than the bottom, then that's going to be less than 1. However, if the top is bigger than the bottom, then that's going to be greater than 1. So this would be growth situation. This would be a decay situation. If the top is bigger, it's growth. In this case, my numerator was smaller than the denominator, so I know that it's going to be decay. Let's look at the second example, though, 3 over 2. So this time, cross out the 5. Since the numerator is larger than the denominator, this is a growth function. 3 over 2 is greater than 1. Last situation has 4 to the negative x. So again, cross out the number in front. Whenever we have a negative in the exponent, we need to take the reciprocal of the denominator. So the reciprocal means flip it. Right now I only have a 4. If I put it over 1, it's easy to see how to flip this. It becomes 1 over 4. It's the power of x. And notice that 1 over 4 is a fraction. The top is smaller, so this is less than 1. And that would be a decay curve. So that was the important thing. We flipped the base, and this became our new base, 1 over 4, which is 0.25 less than 1. Okay, we're almost done. 2 word problems. So number 11 says, you deposit some money in an account that pays this percent interest. I'm going to start underlining all the important numbers. Find the balance after 5 years if the interest is compounded yearly. So whenever I have a compounding problem, I know I'm going to use this formula. A equals P parentheses 1 plus R over N to the power of NT. And this can be found on page 8 in your book. So I need to identify these letters, these variables, P, R, N, and T. Well, P is the principal, or the starting amount. So my principal is 1,500. Let me plug that in. Next, the 9% represents my interest rate, so that's R. Except remember, you're going to move the decimal back 2 spaces to figure out that your rate that you actually plug in is 0.09. And that's the decimal equivalent. It's the same thing as 9%. Next, it says find the balance after 5 years. So that would be my t. And finally, I need n. N represents the number of times you compound per year. If I'm compounding yearly means once per year. That means that n equals 1, since I'm compounding 1 time per year. If it had said compounding monthly, then n would be 12 times per year. If it was weekly, n would be 52. If it was quarterly, n is 4, and so on. Oh, one more. If it's daily, then that means n equals 365, because I'm compounding 365 times per year, once every day. Well, in this situation, n is simple, it's just 1, so let's plug in what we need, what we know. 1 plus my r is 0.09. My n is 1 to the power of n times t, which is 5. I'm going to just simplify some of this stuff for my next step, make it easier to plug into the calculator. 0.09 divided by 1 is just 0.09, and 1 times 5 is 5. So let's plug this in. If you have an Android, you just plug it in from left to right as you see it. If you have an iPhone, you'll want to do it in this order. iPhone people. You'll start with the inside. 1 plus 0.09. So then you should get 1.09. Then you'll hit the button that says x to the power of y and then hit 5. That'll give you this to the power of 5. And in the last step, you'll multiply that by the number in front, 1500. So you're going to have to work backwards, starting in the inside, then the exponent, and then the number in front. Android people have a lot simpler, so I'll do it that way. So we go 1500 times 1 plus 0.09 divided by 1 to the power of 5. My answer, $2,307.93. But there's a 5 right here, so I'll round that up to 94 cents. 2307.94. And that's my final answer. Okay, number 12. Marcus has accumulated a shoe collection. So there are 78 pairs of shoes, all different, all super fly, that can be modeled by this function right here. A equals 78, 0.94 to the power of t. Where A is the total number of pairs and t is the number of days since he received his last pair of shoes. His parents said he can't buy any new shoes until he gets down to 25 pairs. So how many days does he have to wait? So when the question is how many days, that means that's code word for saying what does t equal? Remember, t is the number of days. So if we need to know how many days, we need to figure out what t is. So I'll just write that in a different color to remind myself it's what I'm solving for. Okay, I need to find t. Well, if I need to find t, then everything else should be plugged in. So I need to figure out what goes here for A. Well, it says he needs to get down to 25 pairs. Okay, well, the number of pairs it needs to get down to will go in for A like this. To the power of t. Awesome. So to start solving for t, first I need to get this in proper exponential form. So right now I have it in this form, y equals a times b to the x. Notice that there is a number on the left, there's a multiplier in front, this time it's a 78, and then I have my base and my exponent. I need to make sure it's that number in front disappears. There shouldn't be anything in front, so that way I can go into log form easily. So to get rid of the number in front, I'll just divide, very simply, I'll just divide both sides by the number. That'll cancel it, leaving me with 0.94 to the power of t equals 25 divided by 78, which is 0.3205. Now that I have my base and exponent all by themselves, I can say that I need to go into log form. So I'll bring down the exponent. I'll write log. My base is 0.94 and the leftover is 0.3205. Awesome. So now I've got t by itself, but it equals this crazy expression. So we need to solve that using our change of base formula. And we'll see t equals log of 0.3205 divided by log of 0.94. Remember, the base goes in the bottom. So let's type that in. Log 0.3205, close parentheses, divided by log of 0.94. 18.39 is the answer. So what does that mean? T is the number of days from his last pair of shoes. This means it's going to take 18.39 days until he reaches just the 28 shoes. Or was it 25? No, 25. So I don't know what's happening with his shoe collection, why it's shrinking so quickly. Maybe he's ruining his shoes, maybe he's giving them away, but it's going to take 18.39 days. Now, it doesn't really make sense to say 18.39 days, so let's just say on the 18th day he won't be ready, so then on day 19 he can definitely get another pair because he'll have reached 25 shoes. And that wraps up our study guide review. I hope you found this helpful, and I'll see you next time.